So my name is Ben, JABB of the Carolinas. We grow Beauveria Bassiana. Beauveria Bassiana is a beneficial fungi that we use primarily as a seed treatment of some sort, and we'll get into that a little bit. So Beauveria is an endophyte in the plant, meaning that it's living within the plant, and it does not cause any harm to that organism. Often it benefits its host by enhancing stress resistance, nutrient uptake, and growth. When we look on these petri dishes here, this is what it looks like growing out of a plant. So we can actually culture Beauveria from the plants that we treat, and that's how we isolate our strains, which we'll go into that a little bit as well. On the right side, or maybe it's your whatever side it is, this electron microscope view of a cotton cotyledon, you can see that the mycelial network that Beauveria has within the plant there, and on the bottom picture is the actual spores adhering to that seed coat as we treat it. So like I said, Beauveria is a naturally occurring soil-borne fungi that forms a symbiotic relationship with plants. So what we try to use it as a seed treatment of some sort, because we feel that when that forms that relationship early in that plant's life as possible is when we're going to get the best results. So once that plant germinates, that will stimulate that spore to germinate with that plant, forming that network within the plant through the roots and the stems and the leaves, continues to grow with the plant throughout the whole growing season until the plant finally senesces and dies, and then the Beauveria dies with it. So we see a whole slew of various different things with it. We're stimulating some of that growth below ground, larger root system. We're having resistance to various stresses within the plant, which we'll get into that as well. We're enhancing some of the resistance to various pests and pathogens. Ken touched on that a little bit earlier on how biologicals can enhance that. And we're also increasing the nutrient use efficiency. I really like this illustration from some of the papers I've read about it on the various things that Beauveria is doing within that plant. So we talked about growth promotion there. Beauveria has influenced that plant for various phytohormones such as auxins to help some of that plant growth, especially when we come out of the ground in germination. Often we'll see an earlier germinating plant, more complete germination, so we have a higher plant population versus what's untreated. When we go down below that to resistance against the abiotic stress, the one thing that really always sticks out to me is a reduction of ethylene production. When plants are stressed, plants produce ethylene. Some of you probably have heard it. When we're having a dry year and plants are stressed, they'll tell you to spray a fungicide. Why do we do that? Because the fungicide will reduce the ethylene production within a plant. Beauveria is doing a very similar thing there to pull those stress levels down. Protection against insect pests. Beauveria can also be used as a various insecticide. We don't use it in that way. As an insecticide, the spores would come in contact with the insect, grow within the insect there, ultimately eating it from the inside out. As a seed treatment within the plant, it's really influencing those plant defenses there to make a plant that I don't want to eat. You may still see insects out there, you probably will, but you'll see them not causing economical damage to the plant where you'd have to come and mitigate that. It can also help that plant produce various volatile organic compounds to where an insect would not find that as a suitable host. So it kind of camouflages it where an insect would come in and be like, I probably don't want to lay my eggs on there. I'm going to go somewhere else. Mobile insects such as grasshoppers we'll often see come into a field, maybe feed on the first couple rows, say this isn't quite for me, I'm going to fly and go to the neighbor's field. That tastes a little bit better. Resistance to pathogens, like I said, the endophytic nature of Beauveria throughout that entire plant kind of creates that brick wall. Fusariums or Epithiums, Rhizoctonias are running into a brick wall where they just can't get into those spaces where they need to occupy in order to infect that plant. One important aspect we see, and I know we have some livestock folks in here, is a huge reduction of mycotoxin levels. And that goes back to that resistance of those pathogens I've talked about. We've done a number of trials over the years, specifically looking at the toxin levels within that grain. Very large reductions, especially in the Great Lake regions here, where you often can have issues with that. So from a feedability and marketing standpoint, very big deal. In wheat, when vomitoxins can come in and really cause a lot of issues, we can really pull those levels down and you can have a marketable crop. So this was a Petri dish study that we did. We had some moldy ears that were sent to us. I simply scraped them off into a Petri dish, put Beauveria on the other side, and I just watched to see what happens. I really didn't know what to expect. It was kind of just a little experiment thing. But what we can see is where they meet each other everything just stops and you have that zone of inhibition. So I imagine where that Beauveria is the plant, where that purple is with the field mold, that is the invading pathogen really running itself into a brick wall, and it just can't compete with it. We've talked a lot about John Daniel Schlabach today. This was another trial of his with an agri-energy starter program in SB 120. So on the top, they picked ears out of 1/100th of an acre, much less moldy ears compared to what was untreated. So that goes back to the reduction we have in those toxins. Over the past couple years, I've collaborated with Alex with the Neem Assist, where we've been looking at some corn rootworm programs there and the impact that we can have on that. So on the feeding damage one, that was just a simple a root analysis there based upon the Iowa State on their numbers of the root feeding there. So we can see untreated is high. When we added the Beauveria, we brought it down. Neem Assist alone reduced that feeding even further. But when we put both together, we had that synergistic effect to really pull that feeding down. And the same can be said for lodging, and then finally the yield follow suit with the protection that we saw. On corn trials from the agronomic standpoint there, this was done in Wisconsin. We can see on the graph there, the blue was treated, the orange is untreated. So coming out of the ground, 11 days after planting is when they first noticed germination, we can see that what we've treated continues to come out of the ground faster and more complete than what was untreated there. So that's that influence by those phytohormones within the plant that the Beauveria is helping with. When we look at plant growth, you'll see 3 bars there. That's because this year I played with doing Beauveria as a foliar spray around V4 to see what kind of impact that has. There is a level of stimulation there within the plant, and yield kind of followed that suit. I'm not going to talk too much about it because I'm just not ready to give a formal recommendation with it yet. But ultimately, we see that faster emergence, better plant vigor, better plant health, and that all translates in yield. Soybeans, the exact same story, helping to get out of the ground faster, more complete. And when we did the foliar trial at V4, we saw a real similar response to what we saw in corn. So yield, overall, this year we averaged close to 9 bushels on corn. Typically, we're going to fall within that 5 to 7. Soybeans, right around 3, has been fairly consistent over the years. We've been doing small plot trials in these various spots for close to 4 years now, and it's been holding fairly true. So real quick, we'll just go through the products. SBB 2.5 is your conventional, available both in a liquid form, 1 ounce per acre, that's going to be your in-furrow, and then the talc graphite, 2 ounces per acre, that's going to be in your planter box treatment. SP 120, if you're an organic farmer, that's going to be your OMRI listed products there. And then EndoShield ST, that's for our seed treaters. If you have access to a seed treater or you have a seed treater yourself, this is a real economical way to get this applied to your seeds.